Good afternoon, everybody. It's my great privilege to introduce you today to Miguel Grinberg. He is an engineer at Rackspace. He also quite literally wrote the book on Flask development, something that's been extremely helpful to me as I've been working with Python web engineering. It's available from O'Reilly. Highly recommend you check it out. He's got a great talk for you today about really improving the quality of your REST APIs. So I'll let Miguel take it from there.
Thank you. Okay, first of all, I just want to say something really quick. This was supposed to be a good day for me, but I just learned that my mom passed away today, unexpectedly. So I'm going to dedicate this talk to her. Thank you. So there was a great introduction. Thank you. So most of this, it's already duplication. But yes, I work for Rackspace on OpenStack. I have a bunch of extensions for Flask that are open source on GitHub, and I have a blog that many of you found me and told me that found useful, so that makes me very happy. And then there's the book and a bunch of other things that I did with O'Reilly. So basically, if I can summarize this, I like Flask. That's how I would put it. So today, I'm going to talk about RESTful APIs. This is a topic that generates lots of confusion. If you're implementing a RESTful API and go to, say, Stack Overflow, you're going to find plenty of people that ask, I want to do this or that, and how do I do it in an API? And then always someone comes up and says, no, that's not RESTful, don't do it. And then the person that asked the question is left with nothing. How do I do it? So it's really very confusing, and one of the problems is that the REST paper, the paper that introduced everything, which was published in year 2000 by Roy Fielding, it's very high level. It doesn't talk about doing REST over HTTP. It just describes at a very high level how a REST service should behave. But it doesn't say how to map that into HTTP, which is what we all use to implement our APIs. So the other thing that would be useful is if there was good examples, reference implementations that we can all follow. And to my knowledge, there are none. I don't know any API that I can say that is 100% RESTful, not even the big ones. So another problem, I'm saying I don't think they're RESTful, but it's me thinking that they're not RESTful. The REST paper doesn't really say how HTTP should implement these APIs. So it's really my opinion, and there's a lot of people making opinions. People go make opinions on the internet, or they go to conferences and voice their opinions, and here I am, I'm doing the same thing. So it's kind of a mess. So something that I heard mentioned a lot in the OpenStack environment is that people say, we're doing pragmatic REST. And basically, that's an excuse to say, we are taking the parts of REST that we like, and we're ignoring the rest, or we're ignoring the parts that we don't understand. And is that a problem? I don't think it is a problem. The purists will say that you should not call your API a REST API. But who cares, right? I mean, you can benefit from the REST principles, even if not all of them, just some. So it's still a good thing to follow as many as you find useful. So to be RESTful, according to the purists, you should abide by 6 RESTful constraints. These are the 6 that are specified in the originating paper. So these are the 6. They're listed here in the order they appear on that paper, on that document. So it's really amazing that something that can be listed so concisely, it's so complex. So what I did with these 6 is I rated them from easy, medium, or hard. So I'm going to go over the 6 of them, sorted by complexity. I'm going to start by the easy ones. Okay? And then after I'm done with this, which should be, it's a brief overview. I'm not going to go into a lot of detail. After I'm done with this, I'm going to show you an example. That's another problem. A lot of people, the purists, they say you should not do this, you should do that, but they don't have anything to back it up. So what I'm going to do here is I'm going to show you what I think it's a decent model that it's reasonably RESTful. The purists may say that it's not quite, but I think it's close, if it's not right there on the mark. So let's start. So the first one, it's optional. So you can ignore it. Don't read this. Just go about things without knowing this, and you're fine, because you can do it or don't, and it's fine anyway. And it's code on demand. What this means is that you can have the server can provide the client code to execute. So we see this every time in web applications, right? You go to, say, twitter.com, facebook.com, anything.com, and you don't only get HTML and CSS, you get a bunch of JavaScript, jQuery, and whatever else, right? And then that runs in the browser. For APIs, I don't think this is that useful. So I've never seen it done successfully. And the main problem is that one of the topics that I'm going to repeat a lot here is that APIs, REST APIs, are all about scalability. So if you want to support as many type of clients as you can't rely on the browser being the only type of client. So I mean, what do you send to the client? If you send JavaScript, what if it's an iPhone running Objective-C or Swift? It kind of creates a problem. So I don't do this. And if you know of any project that does this successfully, I'd like to know, because I haven't seen any. So for the rest, not all of them, but the next few, I'm going to use pictures. So this is going to be easier, I think. So the second one, which is also in the easy category, is client-server. And this should be, I mean, everybody gets this. So this is super easy. The idea here is that you should have the API separated from the client. And that doesn't mean that they need to be physically in different machines, different hosts. They need to be in a different process. The API should be a different process, at least. It can be hosted on the same machine as the client. And the important thing is that the client and the server talk over network protocol. But why? Remember I said I was going to repeat scalability a lot? So if you do it this way, then it's super easy to go to this. Now you have one API serving multiple clients. So this is one aspect of scalability that is, basically, if you follow this principle, you get it for free. Okay? So next, we're going into the medium complexity ones. The next one is called layered system. What this says is that the client and the server may not talk directly, that there might be some box, some mysterious box that nobody knows what it does in the middle. The client doesn't know it's not talking to a server. The client talks to an IP address and a port. It doesn't know if it's a real server or intermediate server. And the same thing on the other side. The server gets requests, and it doesn't know if it's getting them from real clients or from some box that is in the middle. So the only aspect of this that if you're developing an API, it's important to keep in mind is that on the server, this prevents you from identifying your clients using headers in their request, right? This guy, this server here, is going to get all requests from the same client. There's no way it can tell who's the client, right? So don't do that. There are other ways. I'm going to show you other ways to identify clients. So that's the only limitation. And once again, if you do this, you get this for free. So now that box in the middle that I didn't tell you what it is, one of possible functions is that this guy is a load balancer. So your API starts to become successful and you get load, the server becomes slow, just throw more servers. And to the client, there's absolutely no difference. They keep sending their request to the same IP address and port, And the only difference is that the responses come back quicker. The server responds faster, right? And you can keep scaling this way, horizontal scaling. Next is cache. What this one's saying is that the API server should provide caching directives so that caches that are in the middle, so for example, that box in the middle could also be a cache, could cache the responses so that if a same request comes over and over, it can provide a response without doing a trip to the actual server. So basically, that's you can save bandwidth by doing that way. But going back, tying into the layered system that we've seen before, you can also have caches in the clients. And in fact, if you have web browsers as clients, you do have a cache. All web browsers have a cache. So you may not even need to go out of your client machine to answer a request that's frequently used. So this is cache. Okay? Unfortunately, the next two, the hard ones, I couldn't come up with pictures. I'm sorry. So these are harder to represent, so I don't have pictures for these. This gives a lot of angst to developers, to web developers. People that are used to create web applications, traditional web applications, they expect the API will log users in and then remember them. And stateless says, this constraint says that you can't do that. And the problem is that when you have sessions, it complicates scaling. Imagine before we were seeing that we can go from 1 to 3 servers. If you're storing sessions in the one server that you have, when you go to 3, what do you do? Where do you put the sessions, right? How do you know that a client will go always to the server that holds that session? So it complicates things. It can be solved, but it makes things more complicated. So REST is saying, don't do it. Some people may claim that cookies are kind of a loophole, that you can use cookies, because the difference is that you can store state in a cookie, and that goes to the client. So the client stores it, not the server. And then every time the client sends a new request, it resends the cookie back to the server. So I think cookies are in a gray area. They are maybe RESTful, but probably not. My opinion is that it's not a good idea to use them. And I'm going to give you an example. Let's say the client connects to the server and gets a cookie, and then it goes away for 1 month. During that month, you make upgrades to your server, and you change the format of your sessions. So a month passes, and now you get a request from this client that has an old session in an old format that you don't understand anymore. So you get a problem. So again, it's a problem that can be solved, but it's a complication, so it's better not to do it. So the way to do this is to have clients send authentication with every request. So the server gets a request, authenticates the user, carries out the request, and then forgets completely about that client. And then when the client needs to send another request, it repeats the whole thing. Of course, you're sending authentication-sensitive information over the network every time, so it's very, very important that you use secure HTTP for every endpoint in your API. Okay, so I told these are 6, and I cheated. The fourth one, sorry, the sixth one, uniform interface, it's really loaded. So it's divided into 4 sections. I have 4 slides for just this. It's super complex. And this is the one that basically gives the basic identification to REST, what we all know about REST, which is to send requests to resources, and all that stuff is here. So the first part, 5.25 out of 6, is that resources, you need to identify them. So resource will be any entity in your API. So it could be customer products invoices. If you're doing an API for device, I tend to use to do a project with cameras. I like cameras. So when I create an API for a camera, that's a resource too, even though it's a physical entity. I have a resource for it. So for each resource, you have to provide a identifier, and that's a URL. It doesn't matter how that URL looks. You may think that you have to use the standard slash resource name slash ID. You don't have to. If you want to do them very cryptic, that's perfectly fine. You can do whatever you want. They don't have to be readable, beautiful, or anything. They can be ugly and cryptic, and it's still fine. But obviously, if you're developing a server, you want to have them in a way that you understand. So you can use your own, I guess, your own organization to create these URLs. But they can be however you want. They don't have to be something that the client understand. Second part of these 4 subparts is the representations. This is saying that the resources are not accessible to the client. All the clients see are representations of them. So this means that you don't have to map, say you have a resource that represents a database table. You don't have to map every single thing you have in your table to what you return to the client. You can choose how to represent and transform the entities, these resources, in a way that you think is more convenient for your API. Going back to the example of having a camera, obviously I cannot ship a camera in a resource because it's a physical object. So I come up with I invent some representation that I think is useful, and that's my representation. Representations can come in different formats, and when you're doing this over HTTP, there's all this mechanism where the client and the server can agree on the best format. They negotiate the format. So typically, these days, you see JSON as the only one, and that's actually what I'm going to show you in this example. But if you want to support multiple formats, you can, and HTTP allows it. It's very easy to do. The client needs to make a modification to a resource. It never gets access to the resource directly. It modifies the representation, ships it to the server, and the server then looks at the resource representation and maps that into the actual resource. The representation is separate from the actual resource. Self-descriptive messages, the third one. This is saying that the messages, these requests and responses that the client and server exchange are self-contained. There's no sideband information. This one, it's kind of difficult to interpret. It's subject to interpretation. If you comply with this or not, you can get crazy and you can say that nothing complies, or you can be relaxed and say that most things comply. But basically, what most people do, and I do too, is basically define all the things that you want done about this request in the request and the response. So you send the operation in the request method, which could be get, post, put, and delete, or others. There are others that some people use, but these are the 4 that are the most used. You always operate on a resource, so that's your URL, the URL you send the request to. You need to authenticate always, as I said before, so you use the headers for example, basic authentication in HTTP. Content type and accept headers are for content negotiation, if you do that. If you need to use representations, those go in the body, either the request or the response. And when there's a result coming back from the server, from the server, you get it in the status code of the HTTP response. The last one, this one, nobody does this. You can look at this, go find any APIs, nobody, I really love it. I would love to be wrong about this, but I don't think I am. So let me know. Nobody does this. The idea here is, so Fielding is saying here that the API should work with hypermedia, so you should have links, and the client discovers resources through links that it gets from previous resources it knows about. So basically, at the beginning, the client knows nothing, only knows the URL of the API, the main URL. And from there, it starts discovering all the things that are there. This is another one that is subject to interpretation. You can get crazy, and then it's really impossible to implement this. Or you can be pragmatic and implement a reasonable have a reasonable implementation of this that is actually useful, and that's what I'm going to show you today. Okay, so I think I'm going to stop here. I'm going to show you the example. So demo time. This is open source, so you can write down the repository for this. It's Python. It's done. I'm sure you can guess this. It's written in Flask. I'm not using any extensions for REST. I did the REST by hand using native Flask. In fact, even if I wanted to use a framework, I don't think any framework in Python or any other language will allow me to get to this level of restfulness. I think I will need to jump through hoops to get, especially the hypermedia part done. So I found that it was easier to do it in Flask native. So let's see how that works. So I'm running it here. So I have 3 windows here. The number 1 is the one that's running the server, and I have Redis running on number 2 for one of the things that I'm doing here. Before I start, I'm going to tell you, this is a little trivia. One of the things I'm going to show here, it's kind of not RESTful. So let's see if you can spot it. I'll tell you after I'm done with the demo. So this is, I'm going to use a command line client. So this is HTTP. And I'm going to send a request to the top URL, the root URL of this API. It's running on the Flask development server, so it's localhost 5000. I'm not using HTTPS here because it's running all on my machine. If I were to deploy this, I will have to use HTTPS, of course. So send request. So this says unauthorized. I can't. I can get access. Now, take a look at this, hypermedia. Location header tells me where should I go to get my token. I'm going to use token authentication here. So let's go there. This is telling me 405 method not allowed. Self-descriptive messages again. This is self-contained. I exactly know what's going on here. This is telling me that a GET request to this URL is invalid. So let's try options. The options request tells me what requests this URL supports, and here I can see, okay, so it's a post request. This guy wants a post request. So I'm going to do a post request. And this is telling me I need to authenticate to get my token. So I'm going to send authentication. And I have an account on this, so I'm going to say my username. It's going to ask me for my password, and that's my token. Okay? So now I have a token. I'm going to have to use this on every single request, so I'm going to save it on a variable. Okay? And now I can go back to the very first one, and I can authenticate with my token. Here I get the first thing. This is all I know. This is the only URL I know as a client. And this is giving me a catalog where I see all the resources that I can access and all the versions that this API supports. Right now, there's only one, and there are 3 resources. So most people say, well, OK, you're a human. You have a brain. You can read this and understand it. How can a script, an application, can understand this if it doesn't know any previous knowledge? And that's true. I agree with that view. The resources in an API need to be documented. So the client knows what resources should expect to find. What it doesn't know is where they are located. And this is good because when you in the server needs to, if you need to reorganize your resources, you're free to do it. And the client will not break. So this example is based on the example I showed last year at the API talk I did. So you can go see the PyVideo video of it if you want to find out more. It basically allows students and classes to register. So students register to classes. So let's see what classes we have. So I just take that URL and send a GET request. So here, I'm not seeing the whole thing, sorry. So we have headers. So up there in the headers, you can see there's caching headers, cache control, and etag are for caching. So I'm not going to go into details, but those are, an HTTP cache would understand those and would be able to interpret those and apply caching to this request. What else do we have? We have 3 rate limiting headers. Those are pretty standard in APIs these days. They're telling me how many requests I can do in a short amount of time. And then we have classes, which is the list of classes, and they have meta. So meta is pagination information. And the idea here is that I don't know how many classes I have in this database. It could be a really long listing. So the server enforces pagination. And the information that you get includes page number, number of pages, first, last, next, and previous URLs, all that stuff. So hypermedia, once again. The classes list is a list of URLs. And people don't seem to like this. The reason I do it this way is because by putting the URLs here, the links, I improve caching efficiency. The responses to all these requests might be cached. So it may be pretty cheap to issue these 10 requests and get a response. Now, you may not like this, and I agree. Sometimes this is not, I mean, it's going to be a pain to have to go and get all these 10 requests separately, and you end up issuing a lot of requests. So I'm going to show you other ways to deal with this. But first, this is a collection. So there are a number of options that are documented. So this is not self-discovered. You have to know this. The client needs to know this. So one thing you can do is you can say per page equals 2. And that changes the page size. I can say, I can leave that and add filter. So I can say name greater or equal than P, and name less than Q. This will give me all the classes that start with P. And I can also say sort by name ascending. So I got 2. It tells me down there, this is in the dark blue, the bottom total says there are 3. So there's one more. How do I get the next page here? I don't have to go back to that and edit the URL. I need to get my next URL here, hypermedia again. So sorry, authentication. And just copy paste that. And what did I do wrong here? I'm sorry, I can't hear you. Oh, I'm sorry. Method. Yes. Get. There you go. You're sharp today, I'm not. There you go. Okay, so here's my third one. I had 3. Now, let's use this one, and let's say you don't really want this getting URLs. It's really, having a second step to get the URLs, it's kind of it's painful. So I can do expand equals 1. And that basically replaces the URL with the actual representation for that resource. Okay? So this is Python programming, so how convenient. I'm going to save this. We are going to use this. So I'll save it in a variable. Let's go back to the beginning. So these, we were playing with classes. So now let's look at students. So let's get a list of students. I copy paste this address. So in this database, I have no students. So I'm sure you know this. Typically, when you want to create a resource, you send a post request to the collection URL, this URL here. So I'm going to go ahead and change this to post and see what happens. Oops. but request, self-descriptive messages. So do you know what happened here? There's no data. That's the problem. So documentation says that the student resource has one field. It's called name. So I'm going to say name Susan. And that worked. And hypermedia again. This is the address for the new resource. So if I send a GET request to this one, I get Susan. It's lowercase, so that should be uppercase. So I'm going to go ahead and modify this, and you probably know this too. Put request to a resource URL modifies it. So name properly uppercase Susan. And it says OK. So I'm going to register Susan to a class. You can see here in the representation for Susan, there's this registrations URL. Once again, hypermedia. This is a link to the list of the collection of registrations, class registrations for this one student, for Susan. Which, if I send a request, this is empty. Susan is a new student, so I'm going to create a registration by sending a post request. And I'm going to say class URL. Remember, I saved the URL for the Python class. So there it goes. And now I have another link for this association between a student and a class, this Susan registered to Python class. Oops, I missed one. So I can get this. Keep doing that. And this one has the class URL, self URL. I didn't mention this. All the resources that I have a self URL. They basically refer to themselves. So you have the class, the student, and I'm also including a timestamp. This is the time that the registration took place. And if, let's say, Susan changed her mind, she knows enough Python, so she decided not to take this class. So the way I do that is by sending a delete request to the registration. And that takes care of that. And if I now go back to get the registrations for Susan, now it's empty again. So did you find what was not? On purpose, I didn't mention, I briefly mentioned, you know. No, sir. So he's saying that when I updated the student, I should have used the patch. Normally, some people use patch. I don't really like patch, but some people use it to do partial updates to resources. That was not a partial update. This is a very simple project, so name is all there is. So that was it was correct to use put, even if I liked patch. No. Rate limiting. Remember, now I told you what's the problem. So think which of the principles of the constraints this is breaking. This is breaking the stateless constraint. You cannot remember users. Counting how many times a user contacts the server, it's really a violation. Unfortunately, rate limiting is a must. You have to have it. So that's why I put it in here. The way most people do rate limiting is by checking the remote address. And that would be really bad because, as I mentioned before, when I showed pictures, the remote address might always be the same one. You really cannot trust that. That's really, it's something that you cannot trust. So the way I'm doing it here, and you can look at it in the project, is by using the authentication information. So unauthenticated users cannot be rate limited with this solution that I implemented here. But since all the endpoints are authenticated, it's not a big deal for this particular project. So anyway, that's the demo part. So you probably think I'm crazy, that maybe I spent months, a year, creating all this by hand on Flask without with any extensions, no RESTful support. I just did it all by hand, implemented all this sorting, filtering, expansion, all that stuff. So maybe you're saying that, it's not worth it. I don't know. Let's give up on REST. Let's go back to SOAP. I don't know. So I'm really kidding. It's easy, and you're welcome to look at the project and look at the video of I explained better, a similar project, a little simpler than this one, but the video from last year will be, informational. But just so that I whet your appetite, I'm going to show you one of the routes. Remember when I obtained all the classes that start with P? So how long is that? What you think? The top level, the endpoint for that. I'm going to give you a clue. Fits here. Okay? Another clue. Below. That's it. So this is a database query. Okay? This is the only endpoint-specific code that I need for a collection. All I need to do is write a function and return a database query. This is a database query that hasn't run yet. It's a query that is still yet to run that returns that collection. So in this case, it was all the classes. So using SQL Alchemy, class of query. Okay? So what do I do with this? I decorate this function with a generic decorator. This works for every collection, and if you work with Flask SQL Alchemy, it will probably work unchanged on your project as well. So this decorator takes the query that the function returns and looks at the query string of the URL, and then applies sorting, filtering, pagination, all of that. Then runs the query. It gets the results. It looks at the query string again to see if you want expanded or not expanded results. And based on that, it generates a Python dictionary with the data. So the representations as a Python dictionary. So now you have a list. It's a list inside a Python dictionary with the whole thing. That goes to another decorator. This guy takes the dictionary and renders it at JSON. I could improve this and make it a proper content negotiation. It could support XML and whatever else, HTML, who knows. The JSON decorator puts that in the response body, and then the eTag decorator adds the caching. The caching requires an MD5 hashtag, an MD5 hash, so it looks at the response that the JSON decorator put and creates the MD5 for the cache to work properly. And then finally, I take this whole thing, the function and all the decorators, and I register with Flask under the URL/classes for method get. And if you look at the code, the high-level code, it's pretty much all like this. It's all super simple, and basically, it made writing this project really, really fun for me. So that's all I have. Thank you.
All right, folks, we have about 5 minutes left for questions. The microphone is right back almost in the center of the room, so if you have any questions, please feel free to line up.
Can I pose a hypothetical? I've got a bunch of microservices. Would I want to have a bunch of individual Flask containers, one per resource?
One for resource. Why would you do that? What's the benefit?
In case I want to redeploy one of them, changing that class of resources, not one per resource instance, I mean one per class of resource. So I've got a Flask container that has classes and a Flask container that has students and a Flask container that has registration.
Okay, so you can host separate servers and then put them behind a proxy server that finds which one to talk to. That will be fairly simple to architect, and it doesn't change anything for Flask.
Sorry, were those decorators standard with Flask? I don't have much familiarity with Flask.
No, decorators, this is a feature of Python. It's a language.
No, I mean the ones that you were using. I know
The decorators that I used are mine, so
Okay,
I
you
coded
wrote
them. Actually, I can tell you a little bit more. The collection one, you probably think I'm cheating because I said that this is simple, and of course, all the complexity is in those decorators. The collection decorator, that's the most complex of all those that I showed. It's about 100 lines of well-commented code full of white space. So it's really not that difficult. I wrote it in one day.
But they're available for us to look at?
Yes, the GitHub address, it's all there. So feel free to look at it, and if you have any questions, you're more than happy. I'll be more than happy to answer them.
All right, thank you very much.
Yeah.
You mentioned that you don't like using cookies and that clients should re-authenticate with every request.
Yes.
I'm not entirely clear on that I understand the distinction between using the auth token like you did in your example versus having an auth token in a cookie that gets sent.
I agree that there's a lot of similarities. The problem I have with cookies is that they're not part of the core HTTP protocol. So not all HTTP clients implement cookies. So, for example, let's say if you want to support Arduinos as clients, this is a very constrained platform, 32K of RAM. It's like we're going back to, to the 80s with, Commodores and that type of thing, right? It's very constrained. So having to support cookies might be a burden for that. So, I mean, the whole theme of REST is to, scale and support, as many variants of clients as possible. So I agree that tokens and cookies, and that's why I said cookies are a gray area. But it's really not that, it's not more complicated to use tokens. So,
thank you.
Yeah.
I have used Django REST framework to build RESTful APIs a couple of times, and I see that you have been, I saw your presentation last year as well, and I see that you use Flask and SQL Alchemy. I just was wondering if you have an opinion on which one is better or what's the difference, or
I think you know which one I think is better.
Why?
That's a difficult question. I think we're all different, and I've been doing software for many years. So when I go to a framework that tells me how to do things, I kind of feel constrained. I like to find my own ways to solve problems, and I find Flask the perfect vehicle for me to find the solutions exactly the way I want them. As I said, I doubt you're going to find a framework, a REST framework, that will let you do this. Right? I mean, you're going to have to start jumping through hoops to figure out how to do this hypermedia thing. With Flask, Flask doesn't care, so I just do whatever I want. So that's what I like.
Thank you.
Yes, welcome.
I noticed you chose to version your API via the request URL. Why did you choose to go this way versus using the accept header to version, like putting
for the version?
Yeah, for the version itself.
Yeah, so some people like to put it in the headers. Really, when you write APIs this way, it's really unlikely that you're going to have to version the API. If you need to do a new version, it's probably going to be a really major different version, or you're going to change things in a drastic way. This whole thing about using hypermedia really reduces the risk of you having to create a new version. So I don't think I'm going to need to do new versions. If I need to do a completely new thing, it'll be a different API.
Okay, I just know that I'm working on a REST API now, and I know that some of the objects that I'm going to be returning later are going to include more complicated values or different ones, and I know that I want to version that for later. So I'm struggling to decide whether I should be including that in the URL or in the actual accept header.
So, right, for clients, it's easier to put it in the URL.
That makes sense.
Right, and in this case, even more, because the client doesn't even know that the V2 or the V1 is there, right? Because it's all hypermedia based. Right. If you have to put it in the headers, you need, the client needs to write that header, generate it. So it's a little bit more burden, but it's fine. I think it works. I mean, people do it. So I have nothing, I can't really tell you that it is wrong because it's not.
Okay, thank you.
Yes.
Thanks everybody for coming out. Enjoy your PyCon.
Thank you.